Finally, somewhere over the rainbow, this emphasizes what happens when light goes from one medium into another medium where it moves more slowly, and the fact that the light path is bent. So here is a cylindrical raindrop. It's a raindrop now from your perspective. And you see that if you look at this laser pointer over on the side there, if I move it up and down, it sort of just moves up and down with my hand, as you would expect. Now I'm going to shine it through here. I'm going right through the center. Okay, it diffuses itself a little bit. But if I move this up away from the center so that I'm not going straight through the bottle, instead I'm coming into the bottle up here so the light is hitting at an angle, okay, you'll see, let me get the laser turned on, point it back on, you'll see that if I move up let's say down ever so slightly, it very quickly moves way off the screen. So I've only moved this thing about an inch, okay? But what's happening is that when light enters straight on, perpendicular to the surface, it'll go right through. But when light enters at an angle, because the surface perpendicular is here now, and I was pointing it at an angle, when that happens, the light bends as it comes in. So if I move up, the beam goes down. And that is what's happening in a rainbow. In a rainbow, we show that just as in a prism, you have light entering the other medium and being bent. In addition to being bent, it turns out that different wavelengths of light bend by different amounts, and so we get the colors being spread out. This explains that in a raindrop, there's actually a bending and then a reflection inside the raindrop so that the light comes back out pointed towards you. The fact that that different colors bend by different amounts explains why it is that we see the colors of the rainbow. And the fact that there's this reflection explains why you need to look in the direction that you need to look in order to see a rainbow. In particular, the sun has to be at your back in order to be able to see it. So the poster goes through the geometry of this, why there are colors, the existence of a secondary rainbow, and why you would have a secondary rainbow as well. Accompanying each one of these posters is a several-page piece of information that goes through an introduction of the science concepts. I don't expect you to be able to read this. The summary is over here. It gives the background science. It lists some fun facts about the particular poster. Some common questions and misconceptions. For example, on a typical misconception about the star poster, the eclipse of a star, is that there's a picture of a constellation on there, the constellation Orion. First of all, for people who teach in cities, it may be that young students have never even seen Orion, because although many of us are very used to it, it's not necessarily that easy to see from the middle of the city. But it's a very common misconception that when people look at a constellation like Orion, that all those stars are somehow physically associated with one another and at the same distance, and they're not. They're just projected along the line of sight. And then there are suggested activities that go with the topics as well. In addition, Kim Cole, who was the person who took the early drafts of these posters and made them into beautiful looking graphical devices instead of what I had made, also has been posting science facts of the day on a Facebook link from our Stop for Science webpage.